Hey everyone, welcome to my channel. This is your girl, TheQuirky-ishTutor. It's honestly been a minute since I've uploaded, so I really should be welcoming myself back to YouTube, because I haven't uploaded in a few weeks, honestly. I think it's been a month. But if you're new here, welcome to my channel. This is your girl, TheQuirky-ishTutor, and I mainly upload math tutorials anywhere from algebra to calculus level, basically. So welcome. I'm so glad you can join and just be here watching my videos. So today we're actually going to continue where I left off. I actually was in the whole middle of a whole series. We are doing the whole limit series. So we're going to continue where we left off in that series. So today we are going to learn how to evaluate limits that initially give us a value that is undefined. Now, as a refresher, I'm pretty sure we know what undefined means. However, I just want to refresh y'all that undefined is any non-zero number over 0, such as 1 over 0, or -2 over 0, or even 1,000 over 0. Now, take note that I said non-zero number because if we had a number that's 0 over 0, that would be a different case. It wouldn't be considered undefined, but rather indeterminate. And that's just a whole nother realm. And I actually covered indeterminate limits in the previous videos of this series, so if you want to check that out, I will list that in the top right hand corner. But today we are going to specifically focus on what happens when we get an undefined value. So before we even get started, I kind of want to tell you some cool facts. They might be cool, they might be boring, but some facts regarding undefined values. So I'm not sure if you knew this. I actually learned this my senior year of not calculus, but high school. I learned that an undefined value, any non-zero number over 0, is really infinity. I did not know this until my senior year of high school when I took calculus, but I'm not sure if you knew this. So the reason why we really call some value undefined is simply because infinity is not an actual number. It's a concept, it's an idea of numbers just heading to eternity, I guess. That doesn't make any sense. But that's simply the reasoning why we call a value undefined. So I guess that's interesting, right? But for the purpose of this video and the examples that we go over, there's going to be cases that even though we initially get an undefined value, there will be cases where it'll either be infinity or a negative infinity. So I'm going to show you a method that I like to use to be certain of if the limit is infinity or negative infinity. So let's jump straight into our first example. So for number 1, it says evaluate the following limits. So as you see, for our function, it says f of x equal to 2x all over x minus 3. And there's two parts. So for part A, we have the limit as x approaches 3 from the positive direction of f of x. So what I like to do when I have these limits is first, of course, when I evaluate limits, the first thing I want to do is evaluate what x is approaching. So we're going to plug in 3 into our function. So we have the limit as x approaches 3 from the positive direction, and we're just going to plug in 3 into 2x all over x minus 3. So that will be 2 times 3 all over 3 minus 3. And that will give us 2 times 3 is 6, and 3 minus 3 is 0. So as you see, we get an undefined value. So when this happens, what I like to do is I like to create a table. And we're basically going to select some x values to plug in our function. And these x values are going to be values that are approaching 3 from the positive direction. Now, if you're not understanding what it means to approach a number from the positive direction and negative direction, I completely understand, because it definitely is a new concept, especially if you're first learning limits. It's kind of just confusing. So I'm going to kind of show you a way to kind of understand what this means. If you don't need this and you kind of like want to skip to the solution, I understand. No hard feelings. I got you. I will put the time slot below so you can just skip right to the solution. But in the meantime, I'm going to show you what it means to approach a number from the positive or negative direction. So what I usually like to do is I like to put or make a number line. And since our number that we're approaching is 3, we're going to put 3 in the middle of our number line since that's the number we're focusing on. Then I'll put 4 since it comes after 3, and then I'll put 2 since it comes before 3, to just fill up the number line. So we know numbers greater than 3 would be 4, 5, 6, 7, 8, etc., right? We can also view it differently and say those numbers, since they're greater than 3, they're on the positive side of 3. And since they're on the positive side of 3, we can say those numbers coming from that side and approaching 3 from that direction are approaching 3 from the positive direction. Okay? And if we flipped it around and we focused on numbers less than 3, such as 2, 1, 0, -1, etc., because those numbers are less than 3, they would be considered on the negative side of 3. Therefore, those numbers approaching 3 from that direction would be approaching 3 from the negative direction. So that's just a way I like to conceptualize. So for the purpose of this part A, it's asking for values approaching 3 from the positive direction. So we're going to specifically focus on the interval between 3 and 4 because that will help us target values that get closer and closer to 3 from the positive direction. So if we think of a number close to 3, we can say 3.5, right? That's kind of close to 3, right? But let's think of something even closer, and let's say 3.1. That's getting a little closer to 3, right? And then we can even take it a step further and do 3.01. And then we can even do it a little further and do 3.001. And essentially keep adding zeros. So we'll do 3.0001. And it'll help us get closer and closer to 3 from the positive side. So those numbers are still greater than 3, but we're getting really close to 3. So that's kind of essentially what we're going to be doing with this table. We're going to be using these values that are really close to 3 from the positive direction and plugging it into our function to see what those values are to gain a sense of what our limit is approaching. Okay, so now we're back to the problem and I'm going to make a table. So in this table, of course, I'm going to put up here, we have our x values right here, and then we're going to have f of x. Alright, so if you were staying for the number chart of me explaining the what positive direction and negative direction are, you'll see I pointed out values approaching 3 from the positive direction. So we're essentially going to use those values. I'm going to use 5 values. That should be enough to help us gain a sense of what our limit is approaching. So I'm going to use 3.1, 3.01, 3.001, 3.0001, and lastly I'm going to use 3.00001. Okay, so the next step that we're going to do is we're going to go into our graphing calculator. So in our graphing calculator, we're going to go into where it says y equals, and I should have my graphing calculator on the screen so you can kind of see what I'm doing. So we're going to go into y equals, and we're going to enter our function. So I'm going to scoot this up because to see what our function is again. Okay, so our function is 2x all over x minus 3. So we're going to do 2x all over, and then I'm going to put in parentheses x minus 3 just to be safe. It doesn't hurt to be safe, right? And then we're going to go to second window. And when we do this, we're led to the table setup window, and this essentially allows us to navigate through the table of the function at any x value that we insert. So basically what we're going to do is enter our first value of our table, which is 3.1. And then I'm going to press second graph, and we'll be led to our table. And as you see, the corresponding value at 3.1 is 62, and we're going to write that down. We're going to repeat this process, so I'm going to go to second window again and put 3.01 this time and press second graph. And as you see, the corresponding value is 602, so I'm going to write that down. So I'm basically going to repeat this process until I cover all the x values of the table. As you see, it's kind of repetitive. You just go back and forth between the table setup and the table. So I'm going to actually fast forward this process so you don't have to basically wait for me and everything, because it's pretty straightforward. Okay guys, I am back. Well, I never left, but it seems like I'm back. But as you see, the table is all filled out. So now what we're going to do is look at our x values, or basically our f of x outputs. So as you see, at our first value, 3.1, our f of x is 62. And then it jumps to 602, and ultimately, and at our last x value, we get 600,002. So as you see, it keeps increasing, and it keeps increasing by large amounts. So this indicates that our limit is approaching positive infinity. Therefore, for the answer to this part, the limit as x approaches 3 from the positive direction of f of x is going to be positive infinity. But we can just write infinity, we don't have to do plus infinity. So that will be the answer to part A. Now we're going to move to part B. Okay, so for this part, this time it's asking us to evaluate the limit as x approaches 3 from the negative direction of f of x. So once again, I am going to kind of explain what it means for values to come from the negative direction of 3. So once again, if you don't want to see this and you're like, just take me to the solution, I will have the time below so you can just skip to that. But if you want to see this explanation, just stay for a second and I'm going to explain. So once again, we're going to be led back to our number line, and as you see, we have 3, and then we have 4 and 2. So last time we focused on numbers approaching 3 from the positive direction, and we were able to select those values getting closer to 3 from the positive direction. This time we're going to be doing the opposite, so we're going to be selecting numbers approaching 3 from the negative direction. So the interval we're going to be focusing on is numbers between 2 and 3, because that will help us select values getting very close to 3 from the negative direction. So an example of a value close to 3 would be like 2.5, right? But if we want to get closer, we would do 2.9. And then if we want to get a little closer, we do 2.99. And then a little closer, we do 2.999. And basically keep adding 9s. So that's going to help us get really close to 3 from the negative direction. So once again, I'm going to return to our problem, and we are going to make a table like we did in the previous part. Okay, so now that we have our table, like I showed you on the number line, values, we're going to select 5 values like we did in the previous part. So the values I'm going to select is 2.9. I'm going to do 2.99, 2.999, 2.9999, and lastly 2.99999. Bunch of nines. And again, if you skip the number line, basically what we're doing is selecting values approaching 3 from the negative direction. So as you see, 2.9, 2.999, very close to 3, but not 3, because we don't want 3. We want numbers approaching 3 from the negative side. So we're going to do the same thing. We're going to go into our graphing calculator. We're going to go into, this time we don't really have to go back into y equals because we're dealing with the same function, so we'll do straight into second window and be led to the table setup once again. And we're going to do the same thing we did in the previous part. We're going to enter the values in our table. So we're going to do 2.9 this time, and we're going to do second graph, and we'll be led to our table setup. So this time I get negative 58 as a value. So I'm going to write that down. And then we're going to go back to second window again, and I'm going to do 2.99. I'm going to do second graph. And I get negative 598. So, like I did in the previous part, I'm going to fast forward this part because it's pretty repetitive. You just keep going back and forth. So I'm going to go ahead and fill out this table real quick, and I'll see you in a minute. Okay, so I'm back, guys. As you see, the table is now filled, and now what we can do is look at all our y values. So as you see, for the first value at 2.9, our corresponding y value was negative 58. And then it jumped to negative 598, and at the last value, it jumped all the way down to negative, I think that's 599,998. So as you see, the values, even though they look large, are all negative, so that means they keep getting smaller and smaller. So this indicates that our limit as it approaches 3 from the negative direction is approaching negative infinity. So for this part, I'm going to write limit as x approaches 3 from the negative direction of f of x is going to be negative infinity. So as you see, this table really just helps us get a sense if it's infinity, not infinity, because as you see, even though we know that undefined, a value is usually infinity, it's just a little different when you're dealing with functions, and yeah, this just helps us to see which one it is, basically. So we're going to move on to our second example. So in our second example, we have the limit as x approaches 1 of 2 minus x all over x minus 1 squared. So I want you to take note that what x is approaching, it's just 1. It's not a one-sided limit, so it's not asking for a specific direction. It's just saying the limit as x approaches 1. So keep that in mind. So of course, the first thing I want to do is plug in 1. And it's just standard. I mean, you don't always have to do it if you kind of like have an idea, but I just want to do it for demonstrative purposes. So I'm going to do 2 minus 1 all over 1 minus 1, and that's all squared. So when we evaluate that, 2 minus 1 is 1, and then 1 minus 1 is, that'll be 0, and 0 squared is 0. So as you see, it's clearly undefined because we get 1 over 0. So this time, remember, it's not asking for a specific direction. X is just approaching 1. So when we make the table to see if our limit is approaching infinity or negative infinity, it doesn't matter what numbers we select that approaches 1. We can do the negative direction, numbers that approach 1 from the negative direction, or numbers that approach 1 from the positive direction. It doesn't matter because ultimately it will be the same. But for the purpose of this video, I'm going to show you both ways, so you can see it doesn't matter. So the first thing I'm going to show you is I'm going to select values that are approaching 1 from the negative direction, my bad. Okay, so I have my table. So we're going to focus on numbers approaching 1 from the negative direction. So when we think of 1 from the negative direction, what numbers would be close? So I'm thinking like we're going to do 5 values. So I'm thinking 0.9 would be a good one. 0.99, basically a bunch of 9s. 0.999, and lastly 0.999. Okay, so basically we're going to be testing these values. Now this is a new function, so we have to enter our function first into our graphing calculator into the y equals. So you'll go to y equals once again. And this time, I'm going to put the top and bottom both in parentheses, just to be safe, right? So I'm going to do parentheses 2 minus x all over, parenthesis, and then I'm going to do parenthesis x minus 1, all that squared, and I'm closing that with a parenthesis. Then we're going to go to the second window, and then that's where we're going to enter all our x values of all the values approaching 1 from the negative direction. So I'm going to enter 0.9 first and do second graph, and I get 110. The next value I'm going to do second window is 0.99, and then second graph, and I'll get 10,100. So you already know the deal. I'm going to fast forward this part so you don't have to wait for me to fill this out, because it's pretty repetitive, so I'll see you in a minute. Okay, I'm back, guys. So now the table is all filled out. So now we're just going to look. As you see, we go from 110 all the way down to a number that's just very large. I'm just going to say it's large. I don't want to even try to figure out if it's a billion, trillion, I don't know. But basically, as you see, it keeps growing in large amounts. So this indicates that our limit as it approaches 1 is infinity. Now I told you I'm going to show you the values approaching 1 from the positive direction, showing you that it doesn't matter which direction you pick when x is just approaching 1, because you'll get the same result. So I'm going to make that table real quick. Okay, so this time when we're selecting x values, remember we're selecting x values that approach 1 from the positive direction this time. So this time I'm going to select 5 values. So one of the values I'm going to test is 1.1. I'm going to do 1.01, 1.001, 1.0001, and 1.00001. We're going to plug that back into our function, basically. So we're going to go back into second window, and we're going to enter all these values that fill up the table. So I'm going to do 1.1, and I do second graph, and I get 90 for the first one. So I'm just going to fill up this table, and once again, I'm going to fast forward this. So I'll see you in a bit. Okay guys, so now the table is complete. So once again, we're going to analyze our values. Now take note that yes, the values are different when you compare the table from the negative direction and the positive direction. But in this case, it doesn't matter what the actual values are. It just matters what the pattern of our table is doing. So as you see, our first value is 90, and then at the end, by the last value, once again, it's just a very large number, bunch of 9s and a bunch of 0s. So this indicates that once again, from the positive direction, our limit is approaching infinity. So this just shows you that it doesn't matter what direction you pick, because ultimately the values should be the same. You do not have to do a table for both directions when x is just approaching some value without no direction specified. Okay, I was just doing this for demonstrative purposes to show you it doesn't matter when the limit is not one-sided. So therefore, the limit as x approaches 1 of our function f of x is going to be equal to infinity. So that is everything for the video today. I hope that makes sense. So basically, this is just a simple way to basically find the limits when you're initially given an undefined value. Okay? So I hope that was helpful. We're almost done with our series. Of course, we could have been done quicker if I didn't take this chunky, huge break, but you know, things happen. It is what it is, right? So there should be a couple more videos left for this limit series, and then we move on to a new series, which I'm excited about because I'm getting kind of tired of limits low-key. But that is everything for today, guys, and take care.